Oh, hey, hello. Didn't see you there. Welcome to the Boring Show. This time, we're going to do something a little different. And that is, instead of building something, I'm going to give you a guided tour of some parts of the Flutter SDK. Basically, we'll be reading code instead of writing it. And the idea is that by reading some of the Flutter SDK, the framework code, you and I will understand a little bit more about the inner workings. But it's like looking a little bit under the hood of this beast and seeing what's it all about and how things work. The what I want to do today, maybe there'll be more of these in the future, but today I'm going to drill down all the way from Flutter widget, I mean the widget, stateless widget, to all the way down to Skia draw calls. So basically, like all the levels of abstraction between you and the graphics card. Almost, because Skia is a C library. And this is all. This is one of the cool things about Flutter. The Flutter framework is built and written in Dart, which is the same programming language that you're building your apps with. So you can pick up things from the framework itself. It's not some mystical thing that you can't look at, right? Okay, we'll start by just demystifying the actual code. So I have here the Flutter/Flutter repo. This is where Flutter framework lives. If you go to Flutter organization on GitHub, you'll see that there's a bunch of other things, like, for example, the engine, which is written in C. Then there's samples and the website plugins. But what we're talking about now is Flutter/Flutter, which is the framework. And you can see that there's some GitHub actions here. There's the binary bin directory. As you can see, again, this is very similar to many Dart projects in general, right? You have your analysis options YAML file here, and that's about it for in terms of what you would normally see. Of course, there's git ignore, but bin you probably know if you're doing any Dart development, which is not that. If you've done any development that is not Flutter, you may know about the bin directory, which is short for binary, which is where all the executable source code lives. So here we do have this is like a bash source for Flutter, same for Dart, and then there are the internal things about this. All right, so this is not actually, I was wrong. This is not a Dart thing. In Dart, you would have Dart files here, but here it's really literally the binaries of the tools. Anyway, there's def, which is again something that we're not going to look at today, and that's if you're a Flutter framework developer, if you're developing the Flutter framework, one of the team members or one of the community members of that team, you will like to go into this. So that's why it's dev. That's called dev, and you'll see benchmarks, automated tests, and so on and so forth. Then there's examples, and then there's packages. Turns out that the Flutter framework is a package, and the way that you get it is, and you've seen this before, I'm sure, if you go to any Flutter apps pubspec YAML, you'll see that one of the dependencies of that package or that app is Flutter, and it basically says, like, where do you get it from? Is it from pub? No, it's from the SDK, and in the SDK, it's called Flutter. So this is basically saying, I want to depend on Flutter as a dependency, and that's what it is, right? So we have packages, and it's not just Flutter. There's also Flutter drivers, Flutter test, and others like integration test, which is pretty new. And you have analysis options here as well. But again, we're going to just look at this one. So that's the Flutter framework, the part of Flutter that you're interfacing with if you're building Flutter apps. And it's all written in Dart. Okay, so once again, this is actually a Dart project, right? So you have analysis options, but you also have PubSpec, which is like, this is the Flutter framework. There are some dependencies of the Flutter framework. Characters, which is basically if you're using Unicode, but you want to use it on a more high level or more user-friendly level than what normally Dart gives you. This collection type data and so on and so forth. And there's also this Sky engine thing, which is Flutter, basically. I mean, that's the engine that Flutter works on. All right. So, and again, hopefully, this is like test. These are all the tests. And you probably also know the directory called lib, which is the library where all the Dart files are. And now if I open an app, a random app, and I go to the main screen and I look at imports, here I'm actually importing .ui, but I'm importing Flutter material. So if you ever wonder where that thing comes from, that's here. Flutter, the package Flutter is this, right? So it's a package called Flutter, and whenever you're importing something from a package, you're importing it from its lib directory, library. And material is this, material.dart. So we're not going to go through the whole of material just yet, but that's what it is. The same with services, same with widgets. So services are here, widgets are here. Cool. I want to go and look at the part of the Flutter framework that is the most contained, the least, I don't know, it's just smallest, I guess. And that's Flutter Foundation. You sometimes see it, especially in files like that try not to depend on much. Will I find something like this here? Probably not. Anyway, you can absolutely do import package Flutter Foundation, right? And you'll get to this guy. And as you can see, it's pretty much just exporting other stuff. So, and here I'm going to switch to my IDE because it will be much easier for me to navigate, right? I just wanted to show you this is not some magic where it's really there. It's just a normal repository with normal Dart files that you can check anytime and read through. All right, so let's look at Flutter Foundation. I'll do the usual stuff. If you're familiar with IDEs, you probably know the Control B or Command B key binding, which is this. And that's basically just saying like, oh, I want to go to this file. I think I can do even if I'm on a Mac, but if I hold Command and click, yeah, I'll get there as well. So you probably know this, but you never know. This file coming back here is just a Dart file, right? And you see it's the same exact file. And it doesn't do much. It just says this is a library and it exports all these other things. So export, if you're not familiar, is in Dart. Normally, you don't do it unless you're building a plugin or a package or a framework. But so not really too used in apps, I think. Normally, you just import stuff in apps, right? Let's go back here. So this is what you are normally doing. If you have a library and you don't want to put everything in one file, then you can export, which is basically saying, I want the contents or the public contents of this file to be available to anyone who imports this file, the foundation.dart. And you can do the usual stuff that you are used to from importing. So you can say, I want people who import this file to see these members of package meta, or this file, right? So that's what you get if you do import Flutter Foundation. You get all these little files in all, and plus the meta package. And there are very, if we go to this directory, okay, so maybe it's better to see it here. If you go to source and foundation, I said it's the smallest or the most contained part of Flutter framework, but this doesn't mean that it's just one little file. It's more of them, and you have things like, you probably know about keys in Flutter. That's where they are defined. You may know about, what's there? Well, what are the constants that Flutter gives you? K release mode, K profile mode. By the way, if you don't know any of these are really useful. Like you can look at K profile mode, and it will tell you whether or not you are currently running or in profile mode or not. And this is for free. It's a compile time constant. So you can just ask the app about this, and you'll see it. Found if it's in debug mode or if it's in web. This is funny because it's basically this is kind of a hack where we normally don't know. Dart doesn't know if it's running on the web or not, but I don't know if you can see it actually. I should make it bigger. But identical, I think it's actually says it here. Yeah. JavaScript does not support integers, right? In everything in JavaScript is a number. So in JavaScript, which is what you compile to if you're targeting the web, 0.0 is the exact same thing as 0. And so this is how we find out if it's the web. Right? But it's a constant. It's compile time. So in compile time, Dart can find out, hey, is in this particular target, is it identical? Yes. Okay, we're on the web. Cool. So that's other things. I wonder if there are other cool stuff that you might want to know about. And for sure, if you have the time, I think you will find it very informative if you go through these and just look at what's available for you. Because whatever you're importing, one thing about Flutter Foundation is that even if you're importing something like material, you're also importing widgets. And if you're importing widgets, you're also importing, I think you're importing Foundation. Maybe not. Anyway, Foundation is really easy to import. Trust me. Anyway, so, but today we're not going to go for Foundation, even though it's very, I think maybe at some point we should just go and read through Foundation. Today we're drilling down from stateless widgets to draw calls, right? So here we have my app, which is a stateless widget. And again, same trick. I will just go to where it is located. And stateless widget is located in source widgets. So again, sorry for kind of going back and forth between the repository and the code, but some things are just easier to see in the repository as actual files here. So we are talking about importing this, right? Widgets are, you automatically get things in widgets if you're importing Flutter material, which we're doing here, right? I hope. Yeah, we're doing Flutter material. We're also doing Flutter widgets, but I'm pretty sure, yes, if you're importing Flutter material, you also get Flutter widgets because export widget start. So back to stateless widget. It's an abstract class that extends widget. And I kind of, and this is where it can get a little weird because there's so many ways we can go, right? And I kind of know where to go to get to the render stuff, but let's just explore. We have all the time. This is the boring show. You don't, we'll take it easy here. So widget extends diagnosticable tree. So let's go there. Okay, that is, it does not extend, but it has just diagnosticable. What is diagnosticable? A mixin class for providing string and diagnostic node debug representations describing properties. So that's basically what you see if you're running an app. Sorry, I have to drink this. If you're running an app and you look at something like Flutter Inspector and you see all these little trees there in the inspector and all the details about every widget that you create and some of those that you don't create, that's where this comes from. And it's basically, it can do toString, it can do toShortString, which describes identity. Interesting. And it can also do toDiagnostics node, which I guess, because it's called node, is something that you put in a tree. In a tree of, again, in a tree something like this, which you see when you run Flutter Inspector. I'm not going to run the app just to show you Flutter Inspector, but that's what you see there. Anyway, all right, so that was kind of cool, but probably not getting us to going back here. So now we're in diagnosticable tree. Again, we're inside widget. So a widget and a stateless widget are all diagnosticable tree. Makes sense, right? Because it's a base class for providing diagnostic node debug representations. So that's how you get that tree in Flutter Inspector. ToString shallow, ToString deep, and debug describe children, right? So, and that gives them a list. It gives you a list of diagnostic nodes. So we get a tree. All right, so let's go to widget. So what's a widget? Now, this line is, at one point it starts to make sense and it's kind of mind-blowing. A widget describes the configuration for an element. And if you're new to Flutter, you're like, what's element and what? And that's absolutely fine. I think for like, you should be able to build great apps without ever knowing anything about element, to be honest. I think this is just an implementation detail for most of the stuff that you do in Flutter. But it's also pretty cool, especially if you're coming from the web. So on the web, and from Android, for example, and other places like this, on the web, without using any of the frameworks, you're working with elements. So you have div, you have button, you have P as a paragraph, you have H1 as headline. Those are elements in a tree called DOM. And JavaScript and web programming in the old days before the frameworks came was about manipulating elements. So you could say, hey, I want to take this element and I want to delete it or make it larger or put a style on it or I don't know, put it in a different part of the DOM tree, right? So you could have I don't know, the document, and then you'd say, I want to add a new element to this document on the website, on the web page, and that would dynamically add, for example, a new paragraph. And then later you would say, I want to make this paragraph red. So you would say, query this, take that element and change it onto red color. This is the old times of, possibly even today, the way to program web using the underlying APIs. That's what things like React do for you, or Svelte does for you in the background. And it's not a declarative framework. The web is not declarative. The web is how do you call it? Imperative, right? You say, hey, element, this headline element or this paragraph element will now be red. Class, whatever, or style, color equals red or whatever. I don't remember. That's the DOM, and it's a tree of elements. Flutter is coming from the web. Like the initial team was Chrome developers. What they wanted is make web much faster by removing a lot of things and basically like rebuilding it as if it was as if we started from scratch, right? And so they have this idea of element, which is basically saying that this is what you configure with your widget. So as you're creating your widget tree, in the background, Flutter works with an element tree, which is very similar to what you see on the web. But you don't, like normally, 99% of the time, you don't really care about what Flutter is doing with elements because you're using your widgets, this thing, stateless or stateful, to configure that tree. You declare how it should look like. And then it's Flutter's responsibility to move around things in the element tree and like change them imperatively for you, so you don't need to think about it. Make sense? I don't know. All right, so widgets are the central class hierarchy in the Flutter framework. Cool. I'm not going to read all of this, but it's really, I think it would be helpful for me to read it. I would probably find a lot more stuff here than I'd like to admit. So this is the widget, and every widget, stateless or stateful, has a key. The widget can create the element, which is basically that thing that you can manipulate, but you normally don't because you let the widget do it. I mean, that you let the Flutter framework do it. And then because we talked about it, you want to be able to inspect your tree. It has all these diagnosticable things like toShortString. Okay, it has some overrides of hash code and operator. This is a little weird to me that it's overriding hash code to use Super's hash code. But okay, non-virtual just means that you can't. Wait, what does it mean, non-virtual? Used to annotate an instance member indicates that M should not be overridden in a class that extend or mix in C or M. So just says you can't override it. So this is the end of the line. We're overriding what it did in the top, but you can't do it. You can override. Can update. Oh, that's a static method. Whether the new widget can be used to update an element that currently has the old widget as its configuration. So this is what the Flutter framework uses to basically optimize. Again, every widget is backed by an element, and if you change the widget, that doesn't mean necessarily that Flutter framework will change the element. In fact, that would be wasteful, because a lot of times you're changing your widget, like you're rebuilding your tree to you set state or something, and a new widget comes up, and the only thing is that it's the same kind of widget, like container, but now instead of being blue, it's red. So Flutter framework can be like, hey, it's the same amount of widget, and it has the same key. So I can update the element that is already there with the new information, the redness. A debug concrete subtype. I have no idea what it is. All right, so this was a distraction, because what we actually wanted to do is go to the rendering side of things. So once again, I'm going to go to definition from stateless widget, and we see that it's a widget. Okay. We also see that it creates an element, a stateless element, that is, which is cool. So that's one thing. And then it also builds a widget, which we know, right? So there's not really anything that kind of points us to the rendering side, like how do we actually render it, except for stateless element or element in general. So let's look at that. Stateless element, still in widgets/framework.dart, is an element that uses a stateless widget as its configuration, all right? And it updates. You can see that now we're in the territory where things, that when we use things like dirty, which normally if you have it in your app, you would be pretty unhappy. That is basically things like, oh, I've updated this, I need to mark it dirty so that later some other part of my system can know that, oh, I need to update something based on that. So it's a lot of work, and you have to think about all this, and you have to do a lot of testing, and that's why we don't normally do it, and that's why we do declarative programming, where you don't need to say that this is dirty, this is not, and clear the dirty tag and stuff like that. All right. So stateless element doesn't really do much. It defers to the widget to build itself, and I mean and it has a widget. Let's go to the component element, an element that composes other elements. So I wonder if I just want to skip through this. So elements need to be mounted, meaning that they have, like, they first start outside the tree, that you create them. That element could be something like a button, but not the widget button, but the button that then is manipulated. And it's rebuild, a bunch of try, finally, else statements. There's a build thing, there's visit children, forget child. Okay. Let's look at element now. So now we've drilled down to the backing elements, which are next to we have the element tree next to the widget tree. So, so now we can read about the life cycle of the element. And once again, this is not something, if you're new to Flutter, I'm really sorry about this, because you really don't need to know much of this. It's really only interesting if you're into the workings of Flutter itself. And still, notice how we're not really we're still reading Dart. It's still, classes, abstract classes, and so on. So it's all good. So that's hash code, slot, depth. I wanna find something that renders. Okay. So the element is like a button, right? And it already has some state in it, and it is mutable. It is manipulated by the framework, not by you. Hopefully, um, you manipulate it through the widgets. So the element then creates a render object. It looks like. There's a visitor pattern here. Right. And okay. What's the difference between render object, element, and render object? Oh, it's an element. Right. Yeah. Okay. Okay. So this just goes down the tree to find some element that is also has a render object. Um, but anyway, it's the same thing. It's just if you ask an element for a render object, it will deliver either its own render object or its children's render object. So we go to render object. What's a render object? An object in the render tree. So now we know, some of you know already, maybe, that there's a widget tree, which is basically all for, if you're building a Flutter app, that's all you need to know about. That's the widget tree. Column, row, my app, all of that is just widgets. This is backed by an element tree, which is like the elements that have their states, that is managed by the Flutter framework. And then there's the render object, and that's a render object render tree, and that has things about the rendering. I'm sorry, I'm losing my voice from all this talking. I should have written something. The render object class hierarchy is the core of the rendering library's reason for being. Writing a render object subclass, that's generally don't do that. Again, it's sometimes nice to do that, but not really very, like, it's not needed if you're just writing apps most of the time. Layout, protocol, hit testing, adapting from one protocol to others. Right. So now we're in the territory of rendering. Parent data is how the render object can find out about things in the, I'm not sure if the element or the widget. I think, no, it's actually, well, probably just the parent in the tree. There's all those like drop child, forget child. What's going on? Yeah, this is already starting to get a little, like debug active layout. I guess I mean, this is something that you can use in app code as well, right? Or as many of you already do it. And that's I want to have a getter, basically a field on my class that nobody can write to except me. So I will create a private field, which is denominated in Dart by, if you start the name of a field by an underscore, then that's private. And but what you do is you just create a public field, which is just a getter. There's no setter, and so therefore nobody can touch this except you. They can only read it. And there's a bunch of those. Here you can have pretty big getters. Here's a getter that does a bunch of things. Mostly, I think it's asserts, right? And this only happens in debug. So you're like, okay. Pipeline owner. Pipeline owner. There's the needs layout. Render objects have constraints. That's how the layout algorithm works, but let's not go there now because that's pretty involved. And you can still see, we're deep inside the code of the framework, and everything is pretty well commented. It's well documented in the code itself. Mark needs layout is what the framework calls when it needs to mark something as needing layout. Okay, not very helpful for me to say that. All right, schedule initial layout. Right, so that's where, by the way, again, this would make more sense if we talked about layout algorithm itself, but you can actually read through this and you'll find that this is there's a bunch of asserts that you don't need to read, right? Like whenever you see an assert, this will not run unless you're in debug mode, and this is really there only for to actually catch bugs or just populate some debug info. All right. This is the actual code. Like if it's sized by parent, there's another assert. Yeah. Perform layout. Perform layout is probably where it all works. Rotate. Oh yes, painting. Yes, thank you. I said at the beginning that I want to go to paint calls. So render object, active paint, is repaint boundary, always needs compositing layer, container layer, the compositing layer that this render object uses to repaint. If this render object is not a repaint boundary, it is the responsibility of the paint method to populate this field. Okay. You can set the layer. It's a debug layer. Mark needs compositing bits update. Needs paint. Mark needs paint. Once mark needs paint has been called on a render object, debug needs paint returns true for that render object until just after the pipeline owner has called paint on the render object. So there's a paint on the render object, and I'm looking forward to it. Skipped painting on layer. Okay. Schedule initial paint. All right, so in this case, there's a bunch of asserts. We say what the root layer is, and which I'm imagining is the layer. So Flutter basically like renders on different layers, like in a 2D game, you have layers. That's what I'm assuming that is. And then all this does is it says, hey, the owner of this, which is the owner is the pipeline owner of that particular render object, has a nodes need repaint list, I guess, yes? And we are adding this to that list. So that kind of makes sense, right? It's like, oh, okay, hey owner, you should probably repaint me here. Like I'm adding you to your to-do list. I'm adding me to your to-do list. Replace root layer, bunch of asserts, paint with context. I'm gonna skip it for now. Paint bounds, debug paint. Paint. All right. Paint this render object into the given context at the given offset. Subclasses should override this method to provide a visual appearance for themselves. All right. So we're down inside the widget, and then we realize, okay, so every widget has an element, and then we realize every element creates, or not every element, some elements create a render object. And so we're kind of not inside, we're kind of parallel to the widget tree. And in the render object, every render object, is it every? Yeah. It probably wants to paint itself, right? So let's say this render object is a piece of text or like a little circle. That's what this means. It's paint. So now we're kind of like, it looks like we're done, right? Because this is just, this does nothing. But we can look at the subclasses of render object to see how different render objects actually approach painting themselves. And now, oh, cool. So there's a render image. All render objects by convention start with render, so there's not all of them. Apparently texture box doesn't. I wonder what will be the simplest. As you can see, there's a bunch of them. Render animated size, render shader mask, something very easy to render radio. Custom paint, all right. Render table. Physical shape. I guess I'm gonna go with image. All right, so we have a render image widget. What? Render image. An image in the render tree. The render image attempts to find a size for itself. Wow, the image is painted using paint image. All right, so again, this is not something that you would normally use in your everyday Flutter development. And we're just inside this rabbit hole of the Flutter framework. And we can already see, okay, so this is an actual image. So if you're, I was worried that this might be a different understanding of the word image, but this is an actual image as you would do it. For example, image.asset or image.network. The widget would translate to this because it has an image in it, the image to display. An image, class image, is also defined in the .ui, which is the library that kind of we'll get to that, I think. Right, so this, but we have this. We are in render image, and we want to look at paint. Basically, all this does is asserts and then paint image. So let's look at paint image. Paint image looks like we're still a Flutter lib source painting decoration image. And that's a function. Paints an image into the given rectangle on the canvas. All right. So there's a canvas, there's a rectangle, and there's the image. There's a bunch of asserts and also a bunch of other things. And then there's lots of size arithmetic, blah, 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 size. There's the paint. There's the different optional things like anti-aliasing, color filter, filter quality, inverting colors, arithmetic, destination rectangle. Here we go with the K release mode. We've seen this before. This is in Flutter Foundation. So if we're in Flutter release mode, if you're not in Flutter release mode, then we do all that, which we don't care about really. So I'm gonna go all the way here. So this was just release mode stuff. And now, I mean, debug mode. There's the saving of the canvas, clipping the rectangle, centering, scaling. Where do we actually apply the image? Come on, image. Oh, draw image rectangle. So not that far away from using, if you're familiar with the canvas, custom canvas, what's it called? Custom renderer widget, then this is what it does basically. Except here we have a bunch of other stuff on top of it. So let's look at, so what this tells us is that even if you're using like an image, I want to find out how it's called. API Flutter Dev. You probably know this and you're like, oh, how can you custom painter? Custom painter is a class that lets you paint anything on the canvas which it gives you, and you can just do whatever you want. And apparently, as you can see, even very basic Flutter primitives, basically, like for example image, use the canvas to draw their stuff. So let's look at canvas. I hope that we still have time. Canvas is, long. Canvas is an interface for recording graphical operations. And we can see it's a class that extends native field wrapper class 2. Native field wrapper class 2 tells me that this is very close to native, as in like it calls to some C libraries or whatever to actually do its work, because it's native, and we can't actually go to the declaration here. Okay, so that's how you create a canvas. There's a bunch of things like recorder. Underlying Skia SK canvas is owned by the picture recorder used to. So we're at Skia level almost. Skia, by the way, is this. It's the graphics library that Flutter uses and Android uses and Chrome uses to, and many other things. Kindle, I think, uses it to render things on the screen. So it's very low level, and on top of it, it's very fast. On top of it, many things are built. So Flutter works with Skia, and Canvas looks like pretty close to Skia. Oh, and here we go. All right, so whenever you run canvas.save, that translates to a call, a native call. This is how you do native calls in Flutter. I mean, in Dart. You could use Flutter FFI, which is the recommended way, but you can also rig Dart to do native calls like that. I don't know if we can, if I can show you, but this is how that works. So this is already past what, the scope of our little boring show here, because this literally is like a C function, I think. But let's look at something more interesting than save. Save layer, restore, okay, canvas restore, save count. I want to, all right, scaling. How does scaling look like? Yeah, canvas scale, canvas rotate, skew. I wanted to find something like just drawing something. So draw color, paints the given color onto the canvas. Draw line. No, thank you. Okay. Aha. Draw line asserts a bunch of stuff, and then it draws. It uses this private member called the draw line, and that is again something in the engine or the Skia that does this. So yeah, we went all the way from here, stateless widget, to painting a line on the canvas. We didn't actually, we would have to look at something. This is just a random stateless widget, right? We would have to look at something like a container or button to actually look, like be for our trajectory through Flutter framework to be less meandering. But there you go. Well, we would still come to this particular point. Now I just want to see if I can find this. So what actually happens after you draw a line through here, or the Flutter framework does. You don't normally do this. So we can go to Flutter. I'm pretty sure it's in engine. Okay, engine, and what's going on? Why can I preset? All right, in this repository. well, in this organization, yeah, okay. I was hoping to find like this, but this is a test. And this we've already seen, right? So maybe not there. Maybe there's something going on over there. What if we do this? I was hoping to find like a C file. Oh yeah. Okay, so this is how in C you can do object-oriented. Yeah. Still, what? All right. Anyway, it failed. I hoped to find. Okay. One more thing. One more try. Skia canvas draw line. Ah. All right. So what? Why am I in Microsoft Docs? Okay, I have no idea what I'm doing, but canvas draw line. Nothing. I apparently have no idea. Okay, so this is a path. Anyway, sorry. This was a mistake. This is the worst mistake of my life. I hope that to just go on. I should have stopped when I was when everything was great. When I got to this place. Anyway, after this, it's either C or some other code that I don't understand, and it just draws a line to canvas, and so in conclusion, because Flutter framework is just another library, just another package, you can actually look at the code, you can go to definition, and you can read through all this stuff and be cognizant of all the things that you get for free from there as well. That's why I started with Flutter Foundation, where you get a bunch of really cool stuff that you maybe not even know about, like the constants that you get, right? And you also get all these meta definitions and stuff like that. But it is really nice to be able to just go to, for example, Flutter Material or Flutter Widget is probably a better start, and just look at stuff that seems interesting, like basic. It's in basic, right? There's the mouse region, align. Oh, these are just basic widgets like baseline, backdrop filter, clip over, center, and so on and so forth. How does center look like, for example? Have you ever seen what the center widget looks like on the inside? Bam! You know what that is? It's just the align widget. That's right. A center widget is nothing else than the align widget, because align widget by defaults to alignment to the center, right? But it's kind of weird. It would be weird to only have align. Most people it's better to read Flutter code and see center in it instead of align without any additional understanding what that is. But yeah, the center widget is just align widget, except you can change the where it aligns because it's in the center. All right. Anyway, I hope that this was interesting and helpful. I really hope that you will do the same thing as I just did yourself, and start exploring the Flutter framework. And if you have any ideas of what I should kind of spelunk to next, what we should cover, then please let me know in the YouTube comments. I do read them, and everyone on the team does read them, at least from time to time, to see what you think you people kind of want us to cover. Thank you for watching, and see you next time.